Okay, thanks very much. So I've been asked to talk today a little about land use and biodiversity. What I'm not going to talk about is I'm not going to talk about the differential impacts between 2 and 1.5 on biodiversity directly. There's a session on sensitivity of natural systems this afternoon, one of the parallel sessions, which is dealing with those issues, and Yadvinder may say one or two words about that as well. What I am going to deal with is more the implications of land use change through the mitigation actions that we take and how those affect biodiversity and other ecosystem services. So I've got a little bit on the Paris targets, which is excellent because it means I can get ahead of schedule, because you all know this already, otherwise you wouldn't be here. So I'll talk a little bit about global mitigation potential in the land sector first. So this is just traditional mitigation technologies. So the first thing to note is in the agriculture, forestry and other land use sector, it accounts for about 24% of total anthropogenic emissions. That may not be a surprise to most people in this room, but it is to people in many other communities who think it's all about industry and energy. So nearly a quarter of all our emissions come from the land sector. So it's part of the problem, but that also makes it potentially part of the solution. The AFOL sector is also different from all of the other sectors in that the last decade, actually, it was the only sector that showed decreased emissions. That wasn't because the absolute emissions were less from agriculture. They actually went up a little bit, but it was because we have this decreased rate of deforestation, predominantly in South America, net deforestation, which means that the total sectoral net emissions dropped. So it's part of the problem, but it's also therefore part of the solution. I don't expect you to read this, but this is just showing the sorts of options that are available. There's forestry, forest management, reduced deforestation and degradation, afforestation, manure management, livestock management, restoration of degraded lands, restoration of organic soils, grazing land management, rice management, cropland management. So there's a whole bunch of technical things that we can do in the way that we manage the land that will reduce greenhouse gas emissions and will increase potentially the carbon stocks in those systems. So soils are a significant part of this. About 80% of the mitigation potential in the sector is in carbon sequestration, and part of that at least is in the soils. So there is a potential here to use soils to sequester carbon. So carbon sequestration, we've been talking about it for ages and ages. We didn't realise 5 years ago that it was a negative emission technology until we looked into negative emission technologies and realised that it's one of them. So now I'm publishing all the same papers again and just putting negative emission technologies in and it's all brand new. So if you get one of those to review, forget everything that's published 5 years ago or more. So in the sector, we've got quite a significant potential. So again, this is not one that I want you to read. I just want you to look here because I'm going to move on to another point. These are the technical potentials for forestry in blue and agriculture in these horrible mustard-coloured bands here. And what you can see that this is the technical mitigation potential or the economic potential at quite high carbon prices, so quite a high level of mitigation ambition. And we've got quite a significant potential here in the agricultural sector, but that's all of the mitigation measures, all of the technical ones added together. Shown over here slightly discontinuously is the technical potential that's available in some of the demand side measures. So a greater technical potential in the demand side measures than in all of the supply side measures added together. So this is very, very under-researched, and these are things like dietary change and waste reduction. There's a significant potential here that we're currently not looking at, and there are a handful of papers published between the AR4 and the AR5 that we had to assess. So let's just look at those demand side measures in a little bit more detail. If we look at what we eat, so this is looking at the greenhouse gas intensity per unit of product. Over here on the left, we've got beef, sheep, beef in meadow systems, intensive beef, for example. And over here, we've got pulses, peas, soy, those sorts of things over here. And you can see that there are a couple or several orders of magnitude difference between the greenhouse gas intensity of the foods that we consume here compared to the foods that we consume here. So if we consume less of these products in global diets and move more towards these products in our global diets, then we can have a real significant impact. And that's where that large mitigation potential comes from, through dietary change. So the key point of this is that we're going to be talking a lot about the biophysical aspects of climate and 1.5 degrees here, but there are lots of behavioural changes that are required, not just by the governments, not just by policymakers, but by all of us as individual citizens of the planet, that we need to take our responsibility and change some of our consumption patterns, not just in the agriculture and food sector, but across all sectors. And of course, most people know that. But again, I think it's fairly under-researched compared to the natural science that we know better. Just to hammer that point home, this was a study published in Nature Climate Change in 2014, looking at what happens if we follow current yield trends, what happens if we close the yield gaps, so we've got a sustainable intensification scenario, or what happens if we also superimpose on that a 50% reduction in food waste and also healthy diets. So here we're not talking about everybody in the world going vegan or vegetarian. We're not talking about those hardcore scenarios. We're simply talking about moving over-consuming nations towards a healthy diet and those under-consuming nations allowing them to increase, but only up to the level of healthy diets. And what we find there is that the current yield trends put us into deep trouble. So if we're trying to cut emissions in the sector, under business as usual, with current yield trends, greenhouse gas emissions increase by about 64%. Forest area declines, crop area goes up, we increase our water use, etc. Sustainable intensification has been heralded as something that might save us. It doesn't. It makes things better, but we've still got deforestation, we've still got an increase in greenhouse gas emissions, we've still not got an increase in fresh water use. The only thing that saves us is a combination of this sustainable intensification plus yield gap closure and these demand side options, reduce waste and food. And you can see that it's only with demand side reduction that we can achieve greenhouse gas reductions in that sector. So supply side, the demand side measures rather, are largely under research. We need more work on those, and we need more work on how we may persuade the global society to move towards more healthy diets. It's good for the environment, it's good for health. Already we have a bunch of conflicts potentially between satisfying food demand and biodiversity. So this is some work by one of my first year PhD students, so it's very preliminary. So what she's done here, she's just taken a look at where the soils are suitable for increasing agricultural expansion and where the areas of high species richness are, and she's just looked at the overlap. So it highlights here a few potential conflicts between biodiversity and managing foods for food security. So this is using species richness of plants, animals and birds. With a different index, this is looking at the threatened species as defined by the red list. You see some of the same areas showing up as particularly vulnerable as we try to meet our food security demands, also threatening biodiversity on this different measure. Another thing she looked at was looking at the food security index and looking at a biodiversity index and ranking the countries to see where these biggest threats may be. And again, this sort of analysis is useful to identify where some of these issues may be coming up in a 1.5 degree world, or any world in fact. These things are already on the horizon and are going to cause conflicts between biodiversity and food security. So the next thing I'll talk about is negative emissions. So negative emissions is something that we may use to meet the 1.5 degree target. Andreas just described a meta-analysis on steroids. This was more like a meta-analysis on diazepam. It took about 2 years to come to fruition. That's what happens when you have a gazillion authors. But we eventually got there and put this paper into Nature Climate Change, and it came out earlier this year. And it was looking at the economic and the biophysical limits to negative emissions. And a paper to follow up on that was looking at carbon sequestration and biochar, which weren't included in the Nature Climate Change paper. The reason it's important to look at negative emissions is because the integrated assessment models, when you allow them to play with how we meet the targets of even 2 degrees, a vast majority, about 80% of the models, apply negative emissions to get to where we need to be. So that you give this option to the integrated assessment models, they're cost effective, and the integrated assessment models gobble them up. And the reason it's important is because this is our current trajectory. This is looking at carbon budgets. This is from a few years ago. This is something that Detlev presented in 2012. This is where we're heading at the moment. That's disastrous. If we've got a budget that we imagine of around about 1,000 gigatons of CO2, that's less now, obviously. This is what would happen if we just switched off emissions. We need to then completely switch off emissions before 2040. So that's really going to be difficult. If we start to rapidly phase them down, really, really aggressively doing our mitigation, we may get to where we need to be by 2060. So this sort of pragmatic scenario of stopping emissions now or stabilising them and then reducing them allows us to emit a little more, which gives us this potential for negative emissions to come along and save us towards the end of the century, which people have very different views about. Okay? So obviously, that's going to be difficult. So let's look at the impacts globally. So these are the land-based mitigation options. You can do an assessment from a horrible meta-analysis on what the impacts will be on land, water, nutrients, albedo, energy and cost. You end up with something that the IPCC call an iconic diagram and everybody else calls totally incomprehensible. And what we have here is we tried to collapse everything onto here. So what you can see is that the size of this is the cost. So we've got direct air capture is very expensive. Enhanced weathering is expensive. This is the potential. This is the energy. So very high energy requirements for direct air capture. Energy generated bioenergy with capture and carbon capture and storage. A large land impact associated with BECCs. And also a large water footprint with afforestation and BECCs. Lower for the others. So there's no free lunch, and all of these have their advantages and their disadvantages. Just a quick look then at the impact of BECCS or bioenergy on carbon capture and storage. Again, this is another global overlay. This was just published in Global Change Biology, Bioenergy. It just came out this month. This is just overlaying the current protected areas in green, the areas that will be protected, and the potential for bioenergy. And where these overlap, there's a significant risk of conflicts between bioenergy and biodiversity. So I won't dwell on that. And this is a secondary paper following up, just looking at, it depends on how we set these biodiversity identification. So if this is done nationally, we can minimise the impact significantly and still employ BECCS in some of those areas. So, in conclusion, land-based mitigation can contribute to the Paris targets. There'll be some areas of conflict between biodiversity and food security, though some mitigation measures could deliver benefits to biodiversity, especially those demand-side measures. They create the headspace and free up land that we could then use for other purposes. Negative emission technologies are likely to be needed, whether we like them or not. A number of the nets are based on land. There's widespread implementation will have consequences for land and water and environment. And via their impacts on land, nets could have large implications for biodiversity. And some examples were given there just at the end for BECCS, but we need to do a lot more work on the other negative emissions technologies and look at the impacts. So climate, food, health and conservation policy need to be joined up, obviously, to maximise the synergies and minimise the trade-offs for these land-based climate mitigation targets and biodiversity. Just to leave it on a positive note, I think that whilst we still have these issues associated with it, it's too important to leave in the hands of nerdy modellers. We actually need to get some serious money out there into implementing these things now. We don't have time to mess around saying there are too many risks, and I'll be really frustrated if in 10 years' time there are still modellers saying we now understand the uncertainties a bit better. We need to get on with it and try some of these things out and learn by doing to start to implement these things at scale. Some of them will fall off the radar because they won't work, but that's what we need to do.